These are the answers to the Chemistry 2010 SOL test. Number 1. A student measures the mass of a 1.00 gram aluminum rod as 0.99 grams. The best estimate of the percent error associated with this measurement is? Well, the formula for percent error is the accepted value minus the experimental value. We take the absolute value of this difference, divide by the accepted value, and then times 100. So in this particular case, we have a difference of 1 minus 0.99, which is 0.01, divided by 1. So 0.01 times 100 is a 1% error. The answer is C. Number 2, the most efficient way to determine whether a reaction is an exothermic chemical reaction is to use? Well, the word exothermic means releases heat energy, so the most efficient way is to use a temperature probe. The correct answer is B. Number 3, we have a balanced chemical equation, and we have to determine which type of chemical reaction this is. Now, a synthesis is a reaction in which 2 or more chemicals are combined together and you get only one product. A neutralization involves an acid, which contains hydrogen, a base, which contains the hydroxide ion OH, and you would normally get water and then some kind of ionic compound or a salt. Oxidation reduction is where one element loses electrons and another element gains electrons. But none of these represent the reaction that we are looking at. The correct answer is D, double replacement, because the 2 compounds exchange or switch their partners. So aluminum and barium have switched their partners and they form 2 new compounds. Number 4 is not a multiple choice question, but rather we have to type in the box the correct answer. What is the oxidation number of an oxide ion? Now don't worry about that phrase, oxidation number. Just think of it as the charge on the ion. So on the periodic table, there are patterns for what charges we see. In the first column, those compounds will generally have a +1 charge. Those elements have a +1 charge. +2 for the elements in group 2. The charge on the elements in the transition metal period varies. Then we have charges of +3, and then once we go over to the nitrogen family, which is group 15, the ions have charges of -3, and then in group 16, -2. In group 17, the halogens, the charges are -1, and then finally 0 would be the charge of a noble gas because it doesn't form any compounds. So because they wanted the charge on an oxide ion, the correct answer is -2. Number 5, what is the molarity of a solution with 0.2 moles of potassium permanganate dissolved in enough water to make a 500 milliliter solution? We have to define molarity. Molarity, which is abbreviated capital M, is the ratio of moles of solute, which is the chemical that's being dissolved, divided by liters of the solution. So to make a solution that has 0.2 moles dissolved in 500 milliliters, we have to remember that 500 milliliters is exactly half a liter. So the math we're doing to calculate molarity is 0.2 moles divided by 0.5 liters, so the correct answer is C, 0.4 moles per liter. Number 6, when 92 grams of ethanol are vaporized at its boiling point of 78.3 degrees Celsius, it requires 78.6 kilojoules of energy. What is the approximate molar heat of vaporization of ethanol in kilojoules per mole? So the molar heat of vaporization is what we're looking for, and it has units of kilojoules per mole. The molar mass of ethanol, as determined by looking on the periodic table and adding up the atomic masses of carbon, hydrogen, and oxygen as found in this compound, the molar mass of ethanol is equal to 46.068 grams per mole. Now that we know the molar mass of ethanol, we can convert from grams to moles. So we have 92 grams of ethanol, and that is equal to 2 moles. Since our answer needs to be in units of kilojoules per mole, we have to take the kilojoules and divide by the number of moles. So 78.6 kilojoules divided by 2 moles gives us the correct answer, which is C, 39.3 kilojoules per mole. Number 7, what is the density of an aqueous solution that has a mass of 10.081 grams and 12.5 milliliters for its volume? So density is mass divided by volume, 10.081 divided by 12.5, rounded off to the proper number of significant figures. In this case, 3 significant figures represents the measurement with the least number of significant figures. So 12.5 is going to limit our answer. We round off our answer to 3 significant figures and we get 0.806 grams per milliliter. Number 8, which element has 16 neutrons, 15 protons, and 15 electrons? So in general, the protons represent the atomic number, and therefore we can figure out the identity of the element just from the protons. So 15 protons corresponds to phosphorus. The correct answer is B. Number 9 is another example of they're giving us a chemical reaction and we have to classify it as synthesis or decomposition or another type. So single replacement represents an element plus a compound, and then we get a new element and a new compound. So one element replaces another. As we saw earlier, double replacement is when they both switch partners. So we have 2 compounds. We produce 2 new compounds. Decomposition involves one chemical breaking up into at least 2 or more substances. And then synthesis would be the opposite of that. We have 2 or more substances combined together to make one. So this particular reaction has an element and a compound on each side. The correct answer is A, single replacement. In number 10, we're given that the formula for barium chloride is BaCl2. And the question is asking, why is barium written first? Well, on the periodic table, barium has a charge of +2. Chlorine has a charge of -1. So the formula of barium chloride has Ba first and Cl second. That's because we always write the positive charge first in this type of compound, which is an ionic compound. So the correct answer is C. Barium is written first because it is the positive ion. In number 11, we are given a list of laboratory techniques, and we have to identify which is best to separate a solid from a liquid. So the correct answer is this particular setup where you're pouring a mixture through filter paper. So the process is known as filtration or filtering. The correct answer is C. Number 12, which of these is not required to ensure that stock solutions are free of contamination? Now, contamination is when impurities get mixed with the chemicals. So 3 of these are good practices to prevent contamination. One of these is not necessary. So placing dropping pipettes in stock solution bottles might cause contamination. You don't want to do that. Pouring an excess chemical back to the stock bottle might also produce contamination, so you shouldn't do that. And it's always a good idea to replace the tops on reagent bottles, again, to avoid contamination or spillage. But storing a solution in a brown bottle is not required to keep impurities from getting mixed with your chemicals. Correct answer is A. Number 13, which of these values is most responsible for changing the boiling and freezing points of a solvent? So here is a section from a chemistry textbook, and I've highlighted a certain paragraph. It's talking about the fact that pure water freezes at 0 degrees Celsius, but aqueous solutions freeze at a lower temperature. For example, when we add ethylene glycol antifreeze to a car's radiator, we lower the freezing point. This also raises the boiling point. So lowering the freezing point and raising the boiling point are physical properties of solutions that depend on the quantity of the substance, but not the kind of substance. So it depends on the quantity or the amount. The correct answer is D, the number of solute particles. So that is the most important value responsible for changing the boiling and the freezing point. How much we have, the number of solute particles. Question 14. We are given a chemical formula, NH4NO3. We should recognize that NH4, which has a positive charge, is called ammonium, and that NO3, which has a negative charge, is called nitrate. So correct answer is A, ammonium nitrate. Question 15 deals with molarity again, but this time we're not calculating the molarity, we're calculating the number of moles of this particular substance that are present in 2.2 liters of a 0.60 molar solution. So 0.60 represents the ratio of moles of solute per liter of solution. That means we can use it as a conversion factor to go from liters to moles. So we have 2.2 liters times 0.60 moles per liter, and we get 1.32 moles. Now I would say let's round off our answer based on the measurements to 2 significant figures. So I would enter 1.3 moles for my answer based on the number of significant figures. Number 16 deals with a chemical reaction that has double arrows. Double arrows means that equilibrium is involved. So chemical equilibrium occurs when opposing reactions proceed at equal rates. So we have a forward reaction from left to right, and we have a reverse reaction from right to left. Once equilibrium is established, the concentrations of the reactants and products no longer change over time. So at equilibrium, these concentrations or amounts of reactants and products stay constant. So the correct answer is B. The partial pressures of nitrogen, fluorine, and nitrogen trifluoride will stay constant. Number 17, we are given 89.6 joules of heat. We are given 20.0 grams of iron. The iron's temperature is changing from 30 degrees to 40 degrees Celsius, and they want to know the specific heat of the iron. Now the units of specific heat are joules divided by grams and degrees Celsius multiplied together. So we need to do the following math. We have to take the heat in joules and then divide that by the product of mass, which is in grams, and the change in temperature in degrees Celsius. So 89.6 joules was given, 20 grams was given, and the difference between 30 and 40, that's a change of 10 degrees Celsius. If we do this math, our answer is 0.448 joules per gram degree Celsius, so the correct answer is A. Number 18 is asking which of the 4 substances on this pH scale is slightly basic. We should know that a pH of 7 is neutral. We should know that a pH less than 7 is an acid or is acidic, and that a pH more than 7 is a base or is basic. So slightly basic in this case would be just above pH 7. Correct answer is B, human blood. Number 19, which element will most likely form covalent bonds with fluorine? Carbon, potassium, neon, or tin? So carbon is located here. Its symbol is C. The symbol for potassium is K. The symbol for neon is Ne. And the symbol for tin is Sn. Noble gases do not form any compounds with any other element, so the correct answer cannot be C. Ionic bonds would be a metal and a nonmetal. However, covalent bonds are typically 2 nonmetals. Since potassium is a metal and tin is a metal, that must mean that the correct answer would be carbon, because carbon and fluorine would form covalent bonds since they are both nonmetals. Number 20, they're talking about evaporation, which is changing from a liquid to a gas. Here is a section of a chemistry textbook. Many properties of liquids, including boiling points, reflect the strength of the intermolecular forces. Those are the attractive forces between molecules. A liquid boils. When bubbles of its vapor form within the liquid, the molecules of the liquid must overcome their attractive forces in order to separate and form a vapor. The stronger the attractive forces, the higher the temperature at which the liquid boils. So therefore, the correct answer is overcoming intermolecular forces as it changes from a liquid to a gas. In number 21, we have to balance a chemical equation. So we start with 2 carbons on the left, 4 hydrogens on the left, and 2 oxygens. On the right, we have only 1 carbon. Now we can balance the carbon by putting a 2 in front of the carbon dioxide. To get 4 hydrogens on the right, we would need to put a 2 in front of the water. Now we have a total of 6 oxygens on the right, because 2 times 2 is 4, plus 2 more oxygens makes 6. The correct answer is 3 because they want the coefficient for oxygen in this equation. Number 22 is showing us a cathode ray tube, and they're talking about J.J. Thomson's experiments with cathode rays and these particular particles that a cathode ray is made of. So we should know that a cathode ray consists of negatively charged particles, which are known as electrons. Correct answer is B. In number 23, we don't have a balanced chemical equation, so we're going to have to write one. It says that nitrogen, N2, and hydrogen, H2, are combined to form ammonia, NH3. So here is the unbalanced chemical equation. When we balance the hydrogens, we'll have to put a 3 in front of the H2 to make 6, a 2 in front of the NH3 to make 6, and that balances the nitrogens as well. So therefore, if this is our balanced chemical equation, the ratio of nitrogen molecules to hydrogen molecules should be 1 to 3. So the only diagram that shows a 1 to 3 ratio between the white molecules of nitrogen and the black molecules of hydrogen is choice D. There's a 2 to 6 ratio, or 1 to 3, so the correct answer is D. Number 24, we have a beaker of water placed in a large sealed jar that is attached to a vacuum pump. And as air is pumped out of the jar, the water begins to boil. So which is the correct reason for this? We are lowering the pressure inside this large sealed jar. A liquid boils when its vapor pressure is equal to the external pressure acting on the liquid. At this point, bubbles of vapor form within the liquid. Now that's the normal boiling point at standard pressure of 1 atmosphere. But the effective pressure on boiling point explains why it takes longer to cook food at higher elevations than at sea level, because we have lower atmospheric pressure at higher altitudes. So the temperature at which water boils will be lower than 100. Now that means that when you lower the pressure in this jar, eventually the water can boil even at room temperature. Boiling occurs when the vapor pressure of the water equals the atmospheric pressure, or the external pressure. Correct answer is C. In number 25, we've got to find these elements on the periodic table and then select the elements that belong in the same period. Remember that periods are horizontal rows on the periodic table. So aluminum is Al, germanium is Ge, antimony is Sb, arsenic is As, and gallium is Ga. So the 3 elements that are located in the same period are gallium, germanium, and arsenic. Number 26 requires us to remember Avogadro's number. Avogadro's number, the number of particles, atoms, or molecules in 1 mole of a substance. 6.02 times 10 to the 23rd. So because we're starting with molecules and we're converting into moles, we put molecules on the bottom, we put 1 mole on top, and we do this math, 2.04 times 10 to the 24th divided by 6.02 times 10 to the 23rd. Correct answer is B, 3.39 moles of water. In number 27, we have to figure out the name of FeCl3 using the proper rules for nomenclature. Essentially, how do we name FeCl3 according to our rules? Well, remember that the iron has a charge which varies because it's in the middle of the periodic table in the transition metal region. Chloride, we know, is -1 because of where we find it in the halogen section. Now, the name of iron has to have a Roman numeral because it can form more than one charge. But the name of the chlorine atom, it becomes chloride. So the charge on iron has to be +3 in this case because there's 3 chlorines to go with it. So the answer is iron, Roman numeral 3, chloride. Correct answer is D. All right, for this next question, we have an expandable container of oxygen gas. The volume is 125 milliliters. The temperature is 25 degrees Celsius. And they want to know what volume will the gas occupy at 55 degrees Celsius. So the temperature is changing, and we have to figure out what the new volume is. From our study of gases, you should know that volume and temperature are directly proportional. So as you heat a gas and the temperature gets higher, the volume gets higher as well. So this can be written as V1 over T1 equals V2 over T2. So a direct relationship between temperature and volume. Now don't forget to convert your temperature from Celsius into Kelvin. So when we add 273 to 25 degrees Celsius, we get 298 Kelvin. And when 55 plus 273 is done, we get 328 Kelvin. So we're going to set up V over T equals V over T. So 125 milliliters over 298 Kelvin equals the new volume, which should be larger than 125 mils over 328 Kelvin. So to solve for V2, it's 125 times 328 divided by 298. We get 137.58. Let's round this off to 3 significant figures. So the answer is 138 milliliters. All right, this question asks, which of these correctly describes how organic catalysts operate in biological reactions? So what exactly is a catalyst? Well, a catalyst makes a reaction go faster. So how does a catalyst work? Well, a catalyst works by providing a lower energy pathway to get from the reactants to the products. So a catalyst lowers the activation energy for a chemical reaction. So the correct answer here is C. They lower the activation energy of the reactions. All right, this question asks, what volume will 35.9 grams of hydrogen gas occupy at STP? Recall that STP stands for standard temperature and pressure, and you should know for the SOL tests that 1 mole of any gas at STP has a volume of 22.4 liters. So we can calculate the volume in 2 steps. First, we're going to go from grams to moles using the periodic table, and then we'll go from moles to liters using 22.4. So 1 mole of hydrogen gas weighs approximately 2 grams per mole. So 35.9 grams of hydrogen divided by 2.016 grams per mole, and then multiply by 22.4 liters per mole because we're at STP. And the correct answer is A, 399 liters. This question is asking us to identify the coefficient in front of H3PO4. This happens to be a double replacement reaction. We're going to balance it by putting the correct coefficients in the right spots. There are 3 calcium atoms on the right, so we'll put a 3 in front of the calcium on the left. There are 2 groups of PO4, 2 phosphate ions on the right, so we'll put a 2 in front of the H3PO4. Now we have 6 hydrogens on the left, so we'll put a 6 in front of the HNO3. Now the equation is balanced, and the coefficient in front of H3PO4 is 2, so the correct answer is B. All right, this question is talking about what happens when we increase the volume of a sealed container that has a gas in it. Now remember that earlier we talked about a direct relationship between volume and temperature. So when you heat a gas, it expands. But here this is about pressure and volume. That's an inverse relationship between pressure and volume. So when you increase the pressure on a gas, you can decrease the volume. But here, if we increase the volume, that's going to decrease the pressure. So correct answer is D, exhibit lower pressure. In this question, we have some data for the melting point of a solid compound. And we're talking about which groups 1, 2, 3, or 4, had the best precision. Remember that precision refers to how close a set of measurements are to each other, whereas accuracy is how close a measurement is to the accepted value. So these numbers don't have to be close to 113, they just have to be close to each other. So which group has the best precision? Group 4, because those numbers are very close to each other. In this question, it says consider any set of 3 adjacent elements in the same period on the periodic table. So for example, we could use boron, carbon, and nitrogen. We could use nitrogen, oxygen, and fluorine. We could use phosphorus, sulfur, and chlorine. They have to be adjacent, so next to each other, in the same period, so the same horizontal row. For which characteristic, atomic number, atomic mass, number of neutrons, or number of isotopes, is the average for the 3 elements always equal to the value of the middle element? So no matter which 3 adjacent elements you pick, the atomic number, which is the number of protons, of the middle element will always be equal to the average of the atomic numbers for the set of 3 elements. So correct answer is A, atomic number. This question is talking about the empirical formula. So the difference between the molecular formula and the empirical formula is that the molecular formula gives you the actual number of atoms in a molecule. The empirical formula gives you the smallest possible whole number ratios. So if I have C2H4, then the empirical formula is CH2. So if 8, 10, 4, and 2 are the subscripts, and we divide each subscript by 2, my empirical formula is C4, H5, N2O. So correct answer is B. This question is asking us to write the formula for diboron trioxide using the symbols provided. So we have letters and numbers. So diboron trioxide, the prefix di means 2 and tri means 3. So boron is capital B. We have 2 of them. Oxygen is capital O, and we have 3 of them. So B2O3. Earlier we had a compound that was iron Roman numeral 3 chloride. Now you see some Roman numerals in the 4 choices that are listed here. However, aluminum is not going to require a Roman numeral because aluminum is always +3. It does not form different charges. Iodide would be the name of the iodine atom as a negative ion. So aluminum iodide, no prefixes, no Roman numerals. Correct answer is D. Here we have a balanced equation. This happens to be a combustion reaction. And we're trying to convert from 6 moles of butane, C4H10, into moles of carbon dioxide. So how do we go from moles of C4H10 into moles of carbon dioxide? We use the coefficients in the balanced chemical equation to set up a mole ratio. Since we're going from butane to carbon dioxide, we need the ratio to be 8 to 2. So 8 moles of CO2 are produced for every 2 moles of C4H10 consumed. 6 times 8 divided by 2 equals 24. The correct answer is B. Here we have 4 structural formulas for 4 different molecules And the question is asking which structure represents a non-polar molecule. Now here you see a variety of molecules. The center one, CCl4, is non-polar. That's because all of the dipoles cancel out. Everything is symmetrical about that molecule, so the 4 dipoles are pulling in equal and opposite directions. Another example of a non-polar molecule is BF3, where the 3 dipoles are going to cancel out. Other examples of polar molecules include HCl, so it's a dipole between the H and the Cl. CH3Cl is polar because the atoms are not the same all the way around. And NH3, because of its trigonal pyramidal shape, is polar because it's not balanced all the way around. If we're looking for a non-polar molecule, we want to have symmetry, so everything is nice and balanced. So as far as which of these 4 molecules is non-polar, everything is nice and balanced and symmetrical in molecule A, so that is non-polar. But molecules B, C, and D are all considered asymmetrical and unbalanced, so they are polar. The correct answer is A. Alright, in this question, it starts out saying using only one trial to collect data in an experiment. Now we normally like to do multiple trials and report the average. It's better to get lots of data and then decide if it's reliable and precise and hopefully accurate. So if you have only one trial, then you're not going to be sure if the experiment is reliable. It causes the conclusion to be less reliable. You would want to take multiple trials in an experiment. So having only one trial, you're less reliable. Question 41. A common product of acid-base neutralization reactions is. Recall that when a solution of an acid and a solution of a base are mixed, we have a neutralization reaction, and we normally get water, and we get some kind of an ionic compound or a salt. So in general, a neutralization reaction between an acid and a base produces water and a salt. Correct answer is B, water. Alright, for this particular question, we have a data table with 4 different solutions. Sometimes the light bulb is bright, and sometimes it's dim. The pH is either 7, more than 7, or less than 7. Remember that an acid has a pH less than 7. Based on the information provided, which solution is a base? So it can't be 3.7, that would be an acid. It can't be 7, that's neutral. So the answer is either NaHCO3 or CH3NH2. One of them is bright and one is dim. The term weak electrolyte refers to a dim light bulb, whereas strong electrolyte would be bright light bulb. So correct answer is D, CH3NH2. This question shows you a data table in which the mass of this particular element, americium-242, is decreasing over time in hours. It starts out at 80 micrograms, and it goes to 40 micrograms in 16 hours. So the half-life, the time required for half the sample to decay, is 16 hours. It takes another 16 hours to go from 40 to 20. It takes another 16 hours to go from 20 to 10. So the half-life is 16 hours. Here in this question we have 2 atoms of bromine. They are connected with a bond, and the question is asking what type of bond is represented between the bromine atoms. We know that ionic bonds are metal and nonmetal, so we don't have that. Covalent bonds are 2 nonmetals. That's what we have. 2 bromine atoms is a covalent bond. So the correct answer is either A or B. In a nonpolar covalent bond, electrons are shared equally. In a polar covalent bond, electrons are shared unequally. Here the 2 electrons are shared equally. It is a nonpolar covalent bond. In this question, a student is studying the effects of several solutions on the prevention of the browning of apples. The student used solutions having different pH values and immersed 3 apple slices in equal volumes of each solution. Now we have independent variable and dependent variable. An independent variable is manipulated by the person doing the experiment. A dependent variable will respond to whatever changes are established by the independent variable. In this case, the student used solutions having different pH values. So because pH was controlled by the person doing the experiment, that's the independent variable. The shade of brown of the apple would be a dependent variable. And they kept the number of apple slices and the volume of the solution constant. All right, this question is a percent error question. We have to determine the density of carbon dioxide because the accepted value for density is 1.96 grams per liter. So what is the experimental value for the density of carbon dioxide in grams per liter? So 0.10 grams of CO2 divided by 0.056 liters gives us an experimental value of 1.8 grams per liter. Recall that percent error is the difference between the two measurements, the accepted value and the experimental value. We divide by the accepted value and multiply by 100. So we have 1.96 minus 1.8 divided by the accepted value, 1.96, and then times 100. This math works out to be 8.2%, so the correct answer is D. All right, well that represents the 2010 Chemistry SOL test. I hope that those answers and explanations were helpful. Thanks for watching.